Alright, you guys, in this video I'm going to lecture about inverse functions. Yeah, this is where we left off last time. Now, in this section, we're going to talk about the idea of an inverse function, how to find out if a function is inverse or not, and to understand how it differs from a normal function. Okay? So, first thing you need to know is the idea or concept of a one-to-one function and what that means. Now, if you remember before, we used to say that if a function is indeed a function, if you graph it like this, what function is this? Do you guys know? That's x squared, right? Now, if this function is actually a function, then that means if I draw a vertical line through it, it will only intersect it at one point. In this case, it's right here, right? This is the point of intersection. And if I draw that line here, 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 it wouldn't matter because it will still intersect it at one point. Now, if you have a function where every single line intersects it at one point except one, then that's obviously not a function. You don't need it to pass once. It only needs to fail once in order for it not to be a function. Make sense? Now, why do we do this? This right here is the idea that every x value needs to correspond to only one y value. Meaning that for this x, you can only have one y, and if you have two, then you have a problem, right? Well, the idea of a one-to-one function is very similar. But for this one, we're focusing on the y aspect of things, which means that for every y value, you can only have one x value. So, again, for my same parabola, if I drew it over again, here's your graph. It's not to scale. Alright? Now, if I draw a horizontal line, since we're testing y, if I draw a horizontal line, it intersects this function twice, which means y equals x squared is actually not 1 to 1. Yes? It is not 1 to 1. This function cannot have an inverse. Now, let me give you the kind of a definition of a one-to-one function is. It is a function f that is considered to be one-to-one if you have a and b in the domain of f, right? So I have a and b in the domain of f, and I'm saying that if a does not equal b, meaning the two values you're considering, these are both x values, the two x values you're considering are not equal, then that should mean that f of a does not equal f of b. Yes? And if they are, so if f of a does indeed equal f of b, then that should only mean one thing, that a itself equaled b. Yeah? So when they're not equal, when you plug them into the function, the results are not going to be equal. And if the results are actually equal, that means that the two numbers initially were equal. Yeah? Meaning that you can't have the same x giving you more than one y value, and you can't have one y value giving you more than one x. Okay, so over here, f of a and f of b, since they're both plugins into the function, if f of a equals the same thing as f of b, that means you have two y values that are at exactly the same point, corresponding to two separate x values, which means it's not one-to-one. So in order for this function to be one-to-one, a and b have to be the same. It has to be the same x value. Alright? Now, let me give you an example. Hopefully that will make things a little clearer. Okay. Here's a fun one. That's one circle. That's another circle. Okay. Oh, my circles look good. Okay. Now, let's call this the domain. Yes? And this needs to be your range. Yeah? Now, in here, I'm going to name elements inside my function or my domain. Let's go. Batman is the first one. Second one is, I don't know, Green Lantern. And the third one is Wolverine. Yeah? So, we'll call this a superhero group. This one would be my villain group. So, we'll see the villains of these guys. I don't know, Sinestro, I think. Right? The Joker. And Sabretooth. Oops. Right? Now, so obviously each one of these villains correspond with only one superhero, right? So Batman goes to which one? It goes to this one, right? Joker. Green Lantern goes to Sinestro, and Wolverine goes to Sabretooth. Would it make sense if I had Joker go to both Batman and Green Lantern? No, because it has nothing to do with the Green Lantern, right? Well, it kind of works the same way. This is your domain, this is your range. What I'm saying is for a function to be one-to-one, each point in your range needs to correspond to only one point in your domain, no more. Alright? Now, this is my superhero group and this is my villain group. Now, look at this for a minute here and see what you notice. The relation between these two is a function, right? So I'm going to call it f of x. My domain, you grab this function, these values, you plug them into your function, and it gives you your range. Now, the idea of an inverse function happens in the following way. You have to flip these two, meaning that for a function to be an inverse of f of x, the range of f of x needs to be the domain of that function. So I'm going to write f inverse right here. And this is how you write it, by the way. So you have like a -1 as a power on top right here. This right here is the format to writing an inverse function. So you read this as inverse of f. Okay, inverse function of f. Now, for this one, even though the villain group used to be the range of the function, it will be the domain of f inverse. And the superhero group, even though it was a domain of f of x, it will now be the range of f inverse. You see that? So the relation here goes in that direction, but over here it's actually going in this direction. So that's what an inverse function is. It's the opposite of what the original function is. What it does basically is that you switch your range and your domain. So if you think about it, if I have a function and I plug it into its inverse and the domain and range of both switch, doesn't that mean they cancel? We're about to find out. Alright, so I'm going to flip this page. If you need time writing down or if I'm moving too quickly, just pause the video. So this is one of the positives about this, I guess. You guys get to pause and rewind as many times as you want. Okay, now let's try this. Okay, now as you can see, there's a relation between inverse functions, and like we covered in chapter 2, we talked about how to do composition between functions, if you remember those, fog and goff, right? if you remember, what did we say? This one right here is what? This will be the multiplication between functions, but in a different way. So we're not actually multiplying one function times the other. What we're trying to do, oh sorry, let me try and focus this. There. What we're trying to do here is plug one function into the other, right? So the function on the outside is the one that's going to be written first. So this one outside, and then the g is on the inside. That's what that means. So you grab one function, you put it into the other one, and then you find the answer, right? And it would be very similar if I switch them. So if it's composite between g and f of x, then this would be g on the outside, f on the inside of x, right? Well, we're going to use this relation here to check if a function is indeed an inverse of another function, using what we just learned about the domain and range, yeah? So let me give you an example here. Say you have f of x, and it equals 3x plus 6, right? And you have g of x, which equals 1/3 times x minus 2. All right? These are my two functions. Now, using these two, I want you to tell me if g of x is inverse of f of x. But how can I do that? The easiest way would be to check your domain and range. Another way would be to use this method right here. Plug one into the other, right? Now, this looks daunting because I'm asking you to plug in the entire function, but you don't have to look at it that way. All you need is to try out a number or two. You don't need to do the entire function. For example, f of x, as you can see, is a polynomial, right? To the first degree. It's a linear. That means the domain is negative infinity to positive infinity. That means you can choose whatever number you want to be x. They're all available for you to choose. And the same applies to g of x. So we have no worries about the value we choosing. We don't have to worry if the value is inside your domain or not, because both domains include everything, right? So if I go here and I say, okay, I have 3x plus 6, and that's my function f, and I want to find f of 3, right? So I chose the x value 3. So what is this going to equal? We have 3 times 3, because instead of the x I plugged in the 3, plus 6. And the answer is what? So this is a 9 plus 6. The answer is 15. Now, let's go to g. And I want to choose a random value to plug in and find the answer. But here's the thing. To use, oops, man, I dropped my pen. To use this idea, what I need you to do is basically grab the answer you got, plug it in here, and see if you end up with the same x you plugged in initially, right? Because remember, for the inverse function, the domain, which is what we plug into the function, is actually the range, which means it's the answer. And the range of f is going to be the domain of the inverse, which means the answer you get from the first function is what you need to plug into the second one. And once you answer this, if the answer matches this x right here, then these two are inverses. Because the idea of an inverse function is it's supposed to undo whatever the initial function did. Make sense? So let's try that. We have 15, right? So that is 1/3 multiplied times 15 minus 2. So we have 1/3 times 15. What happens? That's basically being divided by 3. 15 over 3 is what? It's 5, right? Minus 2, and the answer is 3. Well, you look at that. They're the same. So that should tell you what? That should tell you that these two are actually And versus g of x is actually the inverse function of f of x. Okay, so that was us doing it using a number. Plugging into the entire function is going to be very similar. Just instead of a number, you're going to do f of x and g of x as a whole. Yeah? So, if I want to do f composition g of x, yes? This is basically going to be f of x with g of x plugged in, right? Okay, so let's do that. First, I'm going to write what f of x is, which is what? 3x plus 6, right? And notice inside of the x, I left a blank, because instead of each x value is when you're going to plug in the g of x. So now, instead of the x, I'm going to write down this whole thing, because that's how you plug it into the function. So now we have a third times x minus 2. Yeah? Now we solve. We have a 3, which is a multiplication between this 3 and the pair of parentheses over here. So 3 times third, they cancel, so forget about those. And then 3 times the negative 2 gives you a negative 6. So you end up with x minus 6 plus 6. And then these two add up to what? To 0, right? So the answer is x. Yeah? When you plug one function into the other and it gives you x, this tells you that these two are indeed inverse functions. Now, let's try this. The opposite one. Now, doing it one way would be enough, but just to show you both ways, I'm going to do it the opposite way. Now we're going to plug in f into g. Yeah? That means that I have g of x with f of x plugged in. Alright, now, g of x is what? 1/3 times x, whatever x is, minus 2. And in this case, my x is what? F of x, yes, which is 3x plus 6. Now everything inside the parentheses needs to get multiplied by the third. So 1/3 times 3x, the 3 with the third are gonna cancel, and you end up with just x. Third times the 6, 6 over 3, that gives you a 2, positive, and then you write down the negative 2 outside. Again, you have an addition that gives you 0, and the answer is still x. So as we saw, these two are actually inverse functions. Alright, let's do one more. Okay, here's another example. In this one, f of x is what? X plus 1 over 5. And g of x is 5x plus 1. Now looking at these two, do you think they're going to be inverse functions? Like, do you guess they're going to cancel each other out? When I usually ask that question in class, most of my students say yes, because they see the 5 and they see a 5 and they go, oh, so over here we're going to divide by it, it's going to disappear. Well, the thing is, this is not multiplied by 5. Now there's this, and besides, if it disappeared, then that means it shouldn't be there. Yeah? So never jump to conclusions, always check. So let's try that. Now, I don't mind if you use the number method or if you use the entire function. Meaning, I don't mind if you grab a number and you plug it into the function here to find out what the answer is, and I don't mind if you grab the entire g function and plug it into f and find out what the answer is. We did both in the first example. I'm going to do both in this example too. Alright? So, first, the number way. Choose a number within your domain. Yeah? So, over here, we have what in the denominator? 5. It's a number. It's not x, which means it doesn't limit your domain. This is still a polynomial. It's just that it happens to be multiplied by 1/5. That's all. So, you can choose any x you want. I'm gonna go with 2. Try to make the numbers more diverse, because like if you choose 1, that's very easy and you could easily get a coincidence. 2 is kind of iffy, but I guess it could work. But just to be safe, let's change it. How about 3? 3 is one of the nastier numbers, so if it works, you know you got it right. Okay? Now, f of 3. That means I'm what? I'm going to plug in 3 into the function. So we have 3 plus 1, which is 4, over 5, and the answer is 4 over 5. Right? Now, the rule says the range of this function is going to be the domain of the opposite function. And the range of that one is going to be the domain of this one. Which means that these two need to flip. Yeah? I'm going to plug this into g of x, and the answer should be 3, in order for these two to be inverses. So let's try that. G of 4 over 5 equals. So over here we have 5 times 4 over 5 plus 1. So the 5 with the 5 on the bottom are going to cancel, and you have 4 plus 1, which is 5. But wait, it's 5, not 3. So that means that this is not an inverse. These two are not inverses. Now let's try using the whole function as a plug-in. Composition between the two. F of g of x. G equals. Now, over here, you have g of x, which is 5x upon 1, and f of x, which is x plus 1 over 5. So, I'll leave the blank space for the x, plus 1 over 5. This is my f of x. Now, inside the f of x, I'm going to plug in g, which goes here. 5x plus 1. Yes? Now, nothing to multiply here. We're just adding, so nothing to worry about. Let's go. We have 5x plus 2 over 5. Now, you can try and think of a way to simplify this. Technically, it is simplifiable. It's just you're gonna break up the fraction, but it's unnecessary work because you can obviously see that they don't cancel out. The final result, no matter what you do, is not going to be x, which is what it needs to be in order for them to be inverse functions. Therefore, this result tells you that they are not inverses. Yeah? So we learned how to determine if functions are inverses or not, but how do we find them? Well, the finding of an inverse function is actually very easy. You start off with the original function, and you apply 4 steps, and with those steps you will find your inverse function. Super, super easy. Now here are your 4 steps. Step number 1. Actually, let me write it. To find f inverse. Yes? Step number 1. You need to replace f of x by y. Remember when we said that f of x is technically y, and any value f of x is actually your y value, right? They're exactly the same thing. We're just saying that y is a function of x. Yeah? So, to avoid confusion and make solving it easier, when I give you the initial function and say f of x equals blah blah, what I need you to do is remove f of x and just write down y. That's step 1. Step 2 would be to interchange x and y. So you're going to switch x and y. What I mean by this is that every x you see is going to flip into a y, and every y you see is going to flip into an x. Step number 3, you need to solve for x. Oh, sorry, for y, because we flipped them. You need to solve for y. And after you're done, last one, you are going to replace every y by f inverse of x. So you remove y again, so you replaced it to make the solution easier, and then you remove it again and put back the functions form. But you're not going to write down f of x, you're going to write down f inverse, because having done the switch and then solving for, you actually found the inverse. Alright? So 4 steps. The first and the fourth are exactly the same. You just need to place y and then remove it by f of x and f inverse. So these are just kind of like the labels. The middle 2 are where you actually did the solution. You switch the x and y, you solve for y, and that should give you your f inverse. Yeah? So let me show you an example and we'll go from there. Alright? Now, here's your first example. We have f of x, and it equals what? It equals 2 plus 1/2 x. That's my function. And I want you to find the inverse. Step 1. We said we're gonna what? Remove f of x and write down y. So that's what I'm gonna do. Y equals 2 plus 1/2 x. Notice my function is exactly the same. The only thing I did was remove f of x and write y. That's it. Okay? Now, number 2. We said we're going to switch each x and each y. So, this y becomes an x, 2 plus 1/2, and then the x becomes a y. You saw that? Now here's a question. What if I give you a function that has more than one x and only one y? It doesn't matter. Each y you see turns into an x, and each x you see turns into y, no matter how many there are. Okay? They don't have to match. Okay. So that was step 2. Now step 3, I need to solve for y. It's on this side. I need to get rid of everything that you have on the y side and move it to the x side. Alright? So, easiest one would be the addition over here. So I'm going to move it to that side. And you end up with x minus 2 equals 1/2 y. Right? Now, the 1/2, how do you get rid of it? You need to multiply both sides by 2. So multiplying here by 2, and multiplying here by 2. And remember, you multiply everything. So 2x minus 4 equals y. There, we solved for y. And step 4, we need to rewrite the y in form of f of x. In this case, it's going to be f inverse equals 2x minus 4. And this right here is your inverse function. We're done. Wasn't that easy? Okay. Let's do another one. Yeah? Now, I'm usually asked this question in class, but since you're not here, I'm going to assume you're going to ask it, and I'm going to answer it for you anyway. How do I know if I got it right? Is there a way to check? Yes, there is. The example we did before we started learning how to find the inverse itself, remember? We said this is how you check if two functions are inverses or not. So all you have to do for this example, all you have to do is, I'm going to write it over here. All you have to do is find the composition between the two functions we just got. So that is f and f inverse. Now don't be confused that they both have the letter f, because before, when it was f and g was the f inverse of f. Make sense? And f was the g inverse of g. So basically, these two are still inverses. It just has a different notation. And so this is a completely separate function than that one. And notice they actually look different too. Yeah? So if I plug one into the other and the result gives you x, then that means that they are actually inverse functions, and you got it right. So let's do that. So this means it's going to be f of f inverse of x, right? So let's solve that. So f of x used to be 2 plus 1/2 times x, whatever x is. And f inverse, which we just found, is 2x minus 4. Now, to solve this, you have a half multiplied by a pair of parentheses. Over here, you have half times 2x, 2 and the half cancel, and you end up with just x. And the half times the negative 4 is a negative 2. Yes? Now, this is this half. Don't forget the addition you have in front. So now we have a positive 2 and a negative 2, and the addition between these two numbers gives you 0. Therefore, the answer is just x. And since we got just x, that means that the two functions we just tested are actually inverses. So it worked out. We got it right. Yes? Now, let's do another example. Here we go. Here's another f of x. It equals 3x over x plus 1. See what I did here? I gave you x in the denominator. This is a what? A rational, right? Okay. So, step 1. What do? We remove f of x and we write down y. So it's y equals 3x over, x plus 1. Yeah? Step 2. We're going to switch each x and each y. So y turns into an x, so I'm writing x equals 3x is going to flip into y over x is also going to flip into y plus 1. See what I did there? Now, step 3, solve. We need to solve for y. How do I do that though? This seems a little bit more complicated than the other one. Any ideas? Now you can pause the video and try to think about it if you want. Now, over here, as you see, we have a denominator. And in class, I usually call this what? A complication, right? How do you get rid of complications? You want to get rid of it. You don't want it to be in the denominator anymore. Now, when we have two sides of the equality, it's actually pretty easy. You multiply by it on both sides to cancel it out from here, right? So if you do that, you multiply by x plus 1 over here, so it cancels, and y plus 1 over here, so it cancels, and y plus 1 over here, so x gets multiplied times the y plus 1, right? The whole thing gets multiplied by y plus 1. So we have x times y plus 1 equals 3y. Yeah? Now, what else can I do here? Well, one way would be trying to figure out how to get these two y's together, but you basically undo what we just did. Instead, I want you to multiply the x into the parentheses, like this. So you end up with xy plus x. Yes? The idea here is I want to get rid of this multiplication and I want to get rid of the parentheses because that makes it easier to maneuver. And it equals 3y on the other side because we didn't touch that yet. Now, this xy can be moved to this side. So when I do that, we have x equals 3y minus xy, like that. Yeah? And then from these two values, I'm going to take y as a common factor, which means it's y times 3 minus x. And over here we have an x. See what I did there? And from here, it should be obvious. What I need to do is simply divide by 3 minus x on both sides. So y equals x over 3 minus x. There, we solve for y. Are we done? Nope. One more step, if you guys remember. Step 4. F inverse of x equals x over 3 minus x. That's your answer. Okay? Now, I have one more example for you before we're done with this section. And that one actually includes a graph, so it's going to be a little fun. I printed it over here to have it ready. So I don't know if I can try and zoom in on this thing. Let me see how that works out. Ah, no, we can't zoom in. Alright, maybe I could do this. So as you can see, here it says, the graph of the function is given. Graph the inverse of that function. You're like, alright, you don't have the equation of f of x. I didn't give it to you. I just told you that this graph is simply f of x. And I want you to graph f inverse for me. Yeah? I want you to graph f inverse, but I didn't give you any other information aside from the graph. Well, first thing you need to do is look at the points themselves and write them down. Over here, this point is what? 1 for x, 4 for y, yes? So 1 and 4. This one is negative 1 for x and what is that one? 2 for y? Negative 1 and 2. Over here we have negative 3 and positive 1. And the last one is negative 4 and negative 2. Right? These are my points. Now, what you need to do is flip whatever these points are. See, remember, we said domain of x is range of f of x. And range of f is the domain of f inverse, right? So over here, domain, which is the x, turns into a range, which makes it the y. And my range, which was y, turns into x. So I'm flipping each point. So over here we have negative 1, 2 becomes what? 2 and negative 1. Negative 3 and 1 is going to turn into 1 and negative 3. And negative 4 and negative 2 is going to be negative 2 and negative 4. Yeah? Now we plot whatever these points are. Okay, so 4 for x, 1 for y. That point goes there. We have 2 for x and negative 1 for y. That point goes here. 1 for x and negative 3 for y. That point goes here. And negative 2 for x, negative 4 for y. That point goes here. Yeah? So the line goes like that, and like that. That's your f inverse. Alright, that's it. If you guys have any questions, just email me. You can ask me as many questions as you want. and to like reference where the part of the lesson that you didn't understand, just like look at the video while you're watching it. Obviously it's going to be time, minutes, and seconds. Just pause it and record that time. You're like, okay, so at minute, for example, 30 with 12 seconds, I didn't understand that section, so I would be able to explain it to you again. Also, you can always rewatch, pause it, rewind, and listen to it again. And yeah, I hope this helps. Stay safe.